We are back. It's week 2, day 3, part 2. 2, 3, 2. It's kind of like a pyramid. 2, 3, 2. We're continuing with the bike race. We have, as of now, we have the basics. We have the bike data class, or it's not really a data class. It has some methods. We have the race, which only has one bike. We're going to have to change that. And it allows its one bike to advance until it's done. So what I want to do is, we obviously, it works, but I think we all can kind of sense that there's something wrong here. Like, it just doesn't do anything. It doesn't tell us. So what we need to do is we need to print out, let's print out the location of the bike. Say, where is it? How fast is it going? And maybe how many ticks it took. That sounds weird to say, ticks it took. So we can track all of that. Like, we have to now decide from a design standpoint how we want to implement that with our code. So let's start with how long the race was. Now, I think we can make this work in either way, but from a design standpoint, I want to kind of talk it out. Would you store how long the race took on the bike or the race? The duration of the race. Store it on the race. So why would you store it on the race and not the bike? I'm not saying that you're wrong. We're just exploring this concept.
Well, because the race class is kind of controlling the overall race.
Okay.
It's looking at all the bikes. If you have the bike storing that, then you're basically making that it's only one piece of data that we need, and you've got multiple objects each holding that same piece of data versus just one.
Right. So one of the unforeseen side effects when you have a bike able to keep track of how long it's been racing is that you start to get in, like, this is, you guys are going to kind of roll your eyes at this, but from a practical standpoint, when each bike can keep track of its own time and you're using that to gauge this race, time becomes incredibly relative at that point. And say for some reason a bike didn't advance its time, now bikes all have different times. Like, bikes could potentially have different times. So we want a single source of truth that says that this has been the duration of the race. And I'm not going to actually use a real time stamp. I'm not going to say, like, oh, the race has been running for 0.03 seconds. I'm going to use, like, a counter. Because really what we have is we have locations, which is 0. Those are whole numbers. And I'm also going to have a counter. So we're dealing with both abstract units. So instead of, like, kilometers per second or kilometers per hour, which would be really fast, we're dealing with units per unit. We're just being incredibly abstract. And I think that that's an easier way for us to get the base model of this going, because if we wanted to progress this and continue to code it out over, a great amount of years, we could change it from being unit over unit to second over foot, or hour or kilometer over hour. We could do that, but right now we just want unit over unit. So let's store the duration of the race. And that's just going to be self.duration is equal to 0. And what we're going to do is we're going to increase that every time the while loop ticks. So what I think I want to do is I want to put it after all of the bikes advance, but before we break out, but after the bikes advance. Because if I put it down here, what would go wrong if I put my advance here? Like, if I put self duration plus, yeah, we'll have it off by 1 because it'll break before it gets a chance to update it. So if I say self.duration plus equals 1, that's going to move all the bikes ahead. It's going to say, okay, we all moved ahead. The duration has been 1 more, and then we can output the bike position. So what I want to do down here is I want to maybe print out the duration. I'm going to say print duration. So this will tell me how long the race took to complete with our bike moving at whatever speed it was moving. Whoops, what did I do wrong? Correct. Self.duration works at 14. So that means that our bike took 14 iterations for it to complete the race. How about this? In bike.advance, let's add some debug statements. So I'm going to say print, and I'm going to say debug. And then I'm going to print off their speed after they've sped up. Kind of want to show you what happens with their speed. So every time that bike advances, whoops. Okay, let's also, wait, you know what I did wrong? I'm sorry. Let me do this the actual right way. And then I also want to show self.position. I kind of want to show what their speed is based on their position right after it. So it's like, see how it's ballooning out of control? Every time we speed up, like our location, that's not exponential. But as our speed goes up, our position goes up that much more. So like, yeah, it's not like a curve that goes like exponential, but it will increase over time. So that's how we're able to visualize what the heck we're doing. Now what I want to do is I want to use this visualization technique to balance out my bike. I want it to possibly not speed up every time. So if I said that a bike, when it speeds up, maybe it has a 50% chance of speeding up, like when it wants to speed up. So let's go back to our code here. What would be a great way to code in my speed up method here a 50% chance of it being able to speed up? By 1.
So with the speed up method, instead of doing plus equals 1, do plus equals random dot choice to 0.
Yep, we can do that. We can say random dot choice between 0 and 1. So now when we run our program, notice here between these two runs that it didn't speed up. Didn't speed up here either. Didn't speed up here. It did speed up here. Wait, no. So it is, okay, never mind. Ignore me. Right here, 5, 6, and 7, it sped up. But also look what it did to our race. Now it used to take 14, now it takes 17. It took 21 this time. Now it takes 28. Our poor bike racer is stuck at 4 miles an hour here for a long time. Now we have 20, 17. So we're adding a little bit of randomness to this. Allows us to say, okay, we can speed up. Now, what about I want to provide a limit? I want to say I don't want to speed up above 5. So if self.speed is less than 5, then you run this. There we go. Look at that. We hit our speed limit. But we're never, so our race now takes 25. We're also, notice that we're never slowing down. We hit our speed limit, and then we're like staying there. Should we possibly slow down every now and then?
So in advance, we can have a, instead of just running speed up, we can do another choice between speed up and slow down. So we probably might not want 50%, but then we could do like we did with true false yesterday and say 1 slow down for 3 speed up or something.
I like where your head is at. I think what we should do, though, is maybe we could do a little bit more straightforward, is that we can use a if random dot random is greater than, and then we can provide the percent chance. So if random dot random is greater than 0.75, what percent chance does that mean for self.speedup to get called?
So what is random dot random empty brackets? Is that between 0 and 1?
Yes, that will give you between 0 and 1. So on a uniformly distributed scale, if you were to say random.random is greater than 0.75, that would mean that you're only left with like a quarter, like 1/4 of a chance of it happening. Because 3/4 of it will be false. So this means that if you have a 25% chance of speeding up here. We could also say else self.slow down. Now this is going to be a problem. Our racer has gone home because not only have they hit this, it takes a 25% chance for them to speed up, but it also is a 50% chance that they actually will speed up when they are allowed to speed up. So that's like some level of math that I can't even comprehend.
And we have no limit on the slowdown.
We have no limit on the slowdown. So we need to, first off, how do we limit the slowdown?
In slowdown, we do if self.speed is probably going to be greater than 1, so it doesn't ever actually stop.
As long as we're changing our speed by units of 0 and 1, then we can get away with that. Or as long as we're never going to increase more than 1 or decrease more than 1. So if self.speed is greater than 1, we want to slow it down. Well, do we want to do that actually? Because if it's greater than 1, it can still get a call from Columbia. Hold on a second. Let me get this. I don't know who the heck this could be. It might be important. Hello, this is Joel. Good, how are you doing?
I thought I knew who that was going to be, and I was right. And I'm glad I took that call. It was the South Carolina Department of Revenue.
And you do not want to miss a call from them. So, very, very pleasant people, though. I was expecting them to yell at me and tell me that I'm a bad person, but no, they're cool. Okay. Okay, so did you all run this? Did you see if this would work? Does this work? Anybody sneak up on my computer and try to run it while I was gone? So I'm going to make a note for Maddie that at 10:42 I came back from my phone call. It worked! But we didn't go very fast. I think, so now we're getting into this idea of game balancing. You know, because we're going to tweak some parameters and we're going to see how our game plays out. So this one bike took 99 iterations to go a distance of 100, meaning that they were mostly just going between 1 and 2 units per unit. Not very good. So that means that we're slowing down way more than we should. So we're going to tweak this parameter here. So let's say 50. All right, now we see that it's gone down to 79. Okay. Is that about how long we want our race to go? So it looks like our racer stayed at 1 to 2. Sometimes they got up to 3. 5 would, like, think of it like on a scale, right? Like on a scale of 1 to 5, 1 would be below average. 5 would be above average. 3, right there in the middle. So we kind of, like, I would expect this person to mostly be around 3, with a variance between 1 and 2 and 4 and 5. So maybe we just need to tweak it a little bit more. Maybe what we need to do is we need to take this random choice out of here, because this is already doing a random choice here. Or what we could do is we could provide another random choice here that it slows down. See what I'm saying? So we have this 50% chance here, then we have another 50% chance here, but we don't have a 50% chance here.
Seems like
Too much randomness?
One random probably would be enough to tweak it rather than having.
I think the one random thing would be enough, but notice that just by adding that random choice here, here, and here, having it all even, took us back down to about just under 40%. So we're like between a quarter and 50%. I kind of like that actually, like, because we're hovering, you know, we're mostly around 1, but we're about 2, and then at the very end we hit up to 3 and 4. I kind of like that. Like that's a good amount of variance there. Okay, cool. So we programmed that one bike. The bike, I feel like the bike is good. It can move forward until it's told to stop moving forward. It doesn't know where the end is. It knows where it is, and it doesn't know how long it's supposed to be going for. So we've essentially got, I think that works. I think that works. Now let's take something else out here. Let's take these random choices out of here and see how that affects things. So if I just change random.choice to 1 and 1, does that lower this to like a 25 or a 10? 28, 32, 48, 37, it lowers it probably about 10 on average. We were around the 40, somewhere between 20 and 40. Now we're, well, I guess we got some outliers. This is looking like I did not need those second random choices.
Mine's without the random choices, it's staying in that 30 to 50 range. Before it was, I think one maybe dropped below 30, but I had at least one like 68.
Okay. So what we're doing is we're tweaking the parameters to see, it's like, is the race long enough? Is given a length of 100, is this how long we want the race to be? 30 iterations. Does that give our racers time to get a competitive edge or speed up enough to take the lead? So I think so. I think for now we can always come back and tweak this.
Say if we were to like implement an upgrade and potentially the bike takes damage, sort of thing, we probably want to add those randoms back in.
Yeah, we can always do that. We can always do that.
Let me see your other file. Mine's not.
Which one, the bike sim?
Yeah.
I have the prints in the bike race inside of the advance.
Okay.
And then I also have one print down here in the race where it prints how long it took to finish the race. Okay. So I'm happy with how the bike wound up. Thanks, Leah. You can give it to him if you want. If you need a ibuprofen or something. Yeah, everybody take one. Pass it down.
Drinks Kool-Aid.
Those are not candy. They're not chewable vitamins. Okay, we're going to have some visitors. You all doing a climate test? No, it's fine. It's fine. It's a worthwhile interruption. Aaron, I just want to point out that I'm sitting on a heating pad over here.
We're gonna cut it out. The thermostat for this room.
That's what we figured because all the perimeter rooms are all warm.
I'm gonna cut it down some so it'll be cooler. And the thermostat for you is actually next door.
You mean in another occupant?
That large unit that sits right here.
Yeah.
It controls here, and then it controls their space as well.
Are they in there very?
She's not very much.
Yeah, that room is mostly abandoned. So like they'll just cut it down to 65 and we'll be freezing in here.
We just turned it down for her the other week, last week. So that's probably why you saw the difference in temperatures.
Appreciate it, man.
Sorry for
See? See? Let the recording show that was well done. Things are going well today, folks. Except for, unless your name's Kevin, things are not going well. Are you taking good timestamps at least? Is everybody taking good timestamps we can share to Kevin later? Because you're going to watch this later. You're not going to retain anything today. I'm just telling you. I appreciate the effort to come in, but you probably should have just stayed home. It's going to be tough to retain with. Anyways, let's stop focusing on Kevin. We've got our race now. We need to have multiple bikes. And I have sort of the framework, like this will work, but we need to adapt it to work with multiple bikes. So I need to be able to say, we don't just have one bike, we have multiple bikes. So let's change it there. I'm not going to erase self.bike yet because I don't want to break the whole program right now. But if I wanted to store multiple bikes, what data structure would you use to store multiple bikes versus just one bike? What are your options?
Well,
a string?
Do a for loop and create multiple individual variables.
Okay.
Do
No, I like that, but that's getting away from that's the next question that I had. The first question is where would you put those bikes in? A dictionary or a list? What do you guys think? We got to have options of dictionaries or lists. What do you think? What are the advantages of using a list over a dictionary? Or what is the property of a dictionary that is not in a list? The order? No, well, both of them are ordered. Exactly. Hey, Kevin, he's here. He's here. The dictionary stores a key of value pair. So that's the way that I like to visualize dictionaries and lists. And this way, you'll never forget the difference between a dictionary and a list. Is that think of it like you have. My parents used to keep all their friends' phone numbers in this little box that was like, it was like a Rolodex or something. State of South Carolina is calling again. And if you wanted like a recipe card or a phone number, you would usually go to like an index or something. You'd say like, okay, I want T for Tatty. I want to open that up and go right to T to Tatty. That's using the T as the lookup. And that's saying the first one in that is going to be Tatty. Now imagine that everybody had a little tab that had their last name on there. It was a really big thing, but everybody had a little thing. So I could just look at it and say, there's Tatty, grab it. That's a dictionary lookup. That is essentially saying, I have an index to look this up and is a very fast lookup. That's why dictionaries are very fast, is because their locations are indexed. So I can say, I want to look up by the key of Tatty, and that will pull that card out. That is a very fast computer operation. But dictionaries, unfortunately, are very big in memory, like relatively speaking. They're not like gigabytes. They're bigger than a string. But let's say we have a list. Now, let's say we have that same Rolodex with no indexes. There's no little tab sticking out. And I say, Zach, go find me the card with Taddy on it. Where do you start? Right, unless you know the actual location. Like if I just said, can you just tell me if there's a Taddy card in this stack? What you're probably going to do is you're probably going to start at the very front and start going through. And that's a list.
Can dictionaries be called by their keys and values?
You cannot look up by value. That is a heftier that you can look them up. It requires a little bit more coding, but typically what you can do is, like, if you want to look it up by value, the first thing you'll do is say, I want all of the values, and then that will give you a list, and you'll say, is my thing in there? That'll say whether or not you should look it up at all. But yeah, it's a bit more work to do that, and it's tough to do that too because values are not unique. So in a dictionary, keys are unique. So if you want to look up a key of Taddy, that will give you the key of Taddy and the value of what that was, like Mike, the string of Joel. Whereas if you say, I want to go look up the key by value, and say I want to go look up Joel to get Taddy, there might be 5 Joels in there, and that's perfectly fine because of how the data structure is stored. But that's not an uncommon use case. Like I do that more often than I think I should, just to say I have a key value store. I need to look up the value and get the key for it because the key might be something useful. Like maybe the key is a letter grade of A, and then the value is like a number. So let's say I want to go to my dictionary and reverse engineer and say, if I have an 89, is that like, what is the key for that? Oh, I can reverse look it up and see that it's an A. It's not easy to do that though, so we'll kind of table that. But so we want to store, like I'll just jump right to it since we're starting to run out of time. I want to store my bikes in a list because when you think of when you look at from a top-down perspective of what a bike race looks like, when everybody's at that starting line, they're in an order. They're just like boom, 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 boom. Now, of course, they have their identifying information, but if I was to take all that identifying information away and you just looked at all of them and I said, give me the first racer, you'd probably look top-down. You'd say on the far left, that's the first racer, the second racer, third, fourth, and fifth. And so that's how we're going to identify them. So I'm going to make, say, self.bikes is equal to an empty list. And then what I want to do is what John said, is I want to iterate over however many racers that I want. Let's say we want like 5 racers. So if I say 4 underscore in range of 5, because remember, that's how you iterate 5 times. And I put an underscore there because I don't care about the numbers 0 through 4. Like you always you can throw that variable away if you don't care what the number is. I'm going to say self.bikes.append a new bike, and I'm done. So I'm just saying 5 times I want to call this code, so it's going to push a new bike that is an association into my list of bikes. So now if we were to look down at this individual race, we have a self.bike that's off to the side, but we also have a collection of 5 bikes ready to go. Awesome. We're getting there. We're getting there. So now I want to advance the bike. I want to advance all the bikes. But I can't call it on self.bike. And I can't call it on self.bikes either. Why can't I call it on self.bikes, by the way?
Because the self.bikes is a list and not a bike.
Self.bikes is a list. So I can't call advance on self.bikes because advance is not a method on a list, on just a list. So that list contains bikes. So I have to go and loop through individually through all of the bikes so that I can call advance on all of them. Okay. So how would you do that? A for loop. Okay. So we say for bike in self.bikes. And then I would tab this over. And then I would just change this to say bike.advance.
watching itself then?
Because self.bike is a completely different bike right here. So I used just regular bike here because I made a local variable for this method called bike. And so this is going to refer to the first bike in the collection, then the second bike in the collection, the third and the fourth and the fifth. Okay, so we've moved all of the individual bikes over. How can I tell if that particular bike's position is greater than or equal to the length of the race?
So sorry to backtrack, but
Yeah.
you did bike.advance because you reassigned the list of variable bike right there. Like on top of it before loop.
You mean like right here or right here?
Right there.
Yes. So I changed that from self.bike.advance because I'm going to get rid of the self.bike.
Okay, and now you're able to access it because you related variable to the list, so that you can have a advance.
Right. So self.bikes is a list of bikes. So when I iterate through it, that means that the first time that that code loops through, it's going to grab the first bike out of that list, so I could call .advance on it. And then the second time it goes through, it's going to grab that second bike, and then it's going to say advance on it. So no matter how many bikes there are in this list, like my bike list could be 100 long. It will make sure that each one of them advances.
And you can't do self.bikes because that's a list, so it just would be invalid syntax.
Correct. Yep. Self.bikes is a list. It doesn't have a method called advance. It has a method. I don't even know what methods are available on a list, but I can tell you by saying dir of list. Oh, wait, no, that's the type of list. I guess it's the same. So I could do .copy, .count, .extend, .pop, .append, all of that stuff, but I can't do .advance because I said because bikes have advance, not lists. Okay, so we've kind of coded ourselves into a corner here. This is not an optimal situation for us to be in. Who thinks they see what I'm talking about? Like when you trace through this code that advance all bike will loop through and advance all the bikes, what happens when you get down here at line 44?
Oh, yeah, you have to change the check it for the wind condition.
Yeah, so where do we check for the wind condition now?
And the start, we're using that if, we can change that if to another for loop to cycle through the list and check each bike.
Yeah, that sucks, doesn't it? The things that everything you said there was right, but the one thing I didn't like about it was that you said we had a for loop again. How, like, does that seem like a problem to have to for loop again? Does it seem like it's a lot of work?
We could do, so okay, we could do,
We could for loop. You know what? Let's explore that. Because there's a bug, there is an inherent bug that always tricks the class with this program. And I always like it because I always like sit back and crack my knuckles and laugh like, ha ha ha, you all failed. But we ultimately solve it by doing a second for loop. Now think of it like this. If I looped through all of the bikes, and the first time I saw a winner, I called a break out of that while loop. What inherently could go wrong with that? Think of this from the point of a video game developer. You don't have to be a video game developer to catch this, but what would happen if you broke out after the first person it saw across the finish line? Think of it like this. Let's think all four of us go out for a race. We all go out and we stretch out. Even Kevin has to run. We'll make sure that we all are out there in the street and there's somebody, Leah's out there watching us all run. What our program will do, essentially, is that every time, and if it's a very slow race, but we all take one step forward based on some random chance. But what she does is, after we all take our step, she goes through and she looks to see if any of us have crossed the finish line. If none of us have crossed the finish line, she says advance again. So I take my random chance, I don't move forward. Zach takes his random chance, he moves forward, and so on and so forth. To the point where we get to the end, and Zach and John are both across the finish line. But Zach is farthest to the left. So Leah goes through and she says, Zach is across the finish line. We're done, let's go. And John's just sitting there like, so am I.
You need to move that if from the start into advanced all bikes in that four, put it within the four. No?
No. What we wind up doing is, so let's think what we might do at that point. So if you both cross the finish line at the same duration point, so at duration 60, both of you are across the finish line. How would we settle that? Like, what would be who's further ahead, right? So what we would do is we would put you two into a situation where we're only looking at you two. Okay, you're a winner, you're a winner. So what we're going to do is we're going to look and see where you both are at, which one of you has a farther duration. We don't care about me and Kevin at this point. So essentially what we're doing is we're putting you two into like a winner's circle or like a photo finish, and we're analyzing which one of you went further. And that's where that second for loop comes in. So what happens is that if it's going to look to see if that particular bike's position is farther along, and it does not declare a winner at that point, the first time through, it says that there's a winner, we're going to put them into the winner's circle. And then it's going to go to the next person and say, are you a winner? No. It's going to go to the next person. Are you a winner? Yes. You go to the winner's circle. And it's going to build the winner's circle through the first for loop. And then the second for loop, it's going to say, how many people are in this winner's circle? Is there one? Okay. If there's only one, that's the winner. If there's more than one, we're going to see which one went the farthest, and that's our winner. So this is coding really, like this is getting really far ahead. This is a very, very long way of saying, I don't want this method anymore because we want to work more in this while loop. So what I want to do is I want to take this method of for bike and self bikes, I want to take that for loop and replace that. So I'm going to get rid of advance all bikes and save it. And I need to make sure that I have my indentation correct. There we go. My indentation is correct now. So the cool thing here is that I have access to this bike now. So I can do this check to see if its position is greater than the length of the race. When I had that in a method, it would have been harder for me to do that. At least to do these two steps together.
Well, couldn't you have done the checks in that other method?
Right, but what I couldn't have done is I couldn't have, yeah, it would have been difficult to break out of there. Because I want to break out when, at the very end of the while loop, if anybody's in the winner's circle. Which we could have done.
Return true or false and then do if method break.
Well, I guess we could have done this. We could have done this. Like, we could have used self here to our advantage. What we could have done is we said, advance all bikes. We could have done the check on that bike's location. And if it is fine, we put them into a winner's instance variable. Like we say winners up here. We can say self.winners is equal to an empty list. And then if this person is farther along, we will push them into winners. We won't break out yet, but we will push them into the winners list. I think I like that way of doing it. Not how I had intended to do it. But I think this is a way without like completely changing directions that we can do this. So let's take this logic that does the if check and put it inside of our for loop. So after this particular bike advances, goodness gracious, if the bike's position is greater than or equal to the length, I don't want to break. I want to self.winners.append the bike. So we're back to a point now where the program will run infinitely now. Because we're never stopping. All of these bikes are now progressing together at an astonishing rate of speed. So how do I, inside of my while loop here, I want to break out of that while loop still. So instead of looking to see if the bike's position is greater than or equal to the self.length, what am I looking for now that I have this winners variable on my race? If anything is in the winners. So if I said, would this work if self.winners?
No, because it's an empty list, which is true.
An empty list is not truthy. An empty list is falsy. So if you have an item in that winners, then we want to break. So this is still the problem we were talking about. A bike, this is all of our bikes locations, a single bike, it was the first bike to cross the finish line. So if I was to print self.winners, it's very unlikely that we would have multiple winners, but it could happen. Maybe if the bike, oh, there we go. I knew it would happen. It always happens. So in this case, we don't say which bike crossed the finish line first, or which one went the farthest. They crossed the finish line at the same time, and we need to sort them. You all have already sorted a list. So I'm going to show you how you can sort a list of complex objects like bikes. Because what do we want to sort on? What value on the bike do we want to sort on? Self.position. It doesn't make sense to sort on anything else. Like we don't sort on memory location or anything. You want to sort on position. So what we're going to do is I am going to, first off, if there are self.winners, I'm going to sort it. So I'm going to say self.winners. Actually, no, I don't need to reassign that. Let's just say our sorted winners is equal to sorted. And then I can pass self.winners is my collection. And then this is kind of weird. This is a new thing. I'm going to pass a lambda function. And a lambda function is just like an inline function that will get called by the sorted function. We're not going to go too in-depth of what they are today. But just know syntax-wise, I'm going to say lambda of x. And then I'm going to say x dot position. This is essentially saying what attribute it's going to sort by. I wish I could just say x dot position here, but I can't. I have to say it's inside of a lambda of x. So again, I'm not going in detail of what's going on here. We're going to talk more about that later this week. Maybe we can do it on Friday. But that will sort our winners. And then we want to print sorted winners 0, because that will give us our winner. It'll work if we have only one winner, and it will work if we have 10 winners. Let's also print our winners too. Self.winners. Must use keyword argument for key function. Okay, let's just say key is equal to. I forgot about that. You have to say key is equal to lambda. Okay, we have one bike. Come on. How many times am I going to have to run this to get 2 bikes? Gosh, it must have been rare for it to pop up that one time. There we go. This is perfect. This is exactly what we wanted to show. We're going to identify these bikes based on their memory location. And so self.winners is the second print that we have here. So this is the unordered list. Sorted winners sorted based on their location. And so it picked the second item in the unsorted list as the winner, which is essentially saying it worked. Yeah, sorry, the sorted is kind of weird. Sorted, the key, did you say key is equal to? x and then x, lambda x colon x position. Mm. Lambda? Yep. It's a type of bread from Lord of the Rings. Is it already warming up in here? Am I just crazy? Or am I just sitting on my heating pad that is currently on medium?
I think it's your game, but
Jury's still out.
Jury's still out. Nobody's brave enough to take their coat off. This could mean a lot, though, if we get the HVAC fixed. That means that
Huge.
Zach can wear his flip-flops.
Shit, no shoes.
No shoes. Although if it becomes a problem, we'll have to tell you.
Sure. Sure.
We'll bring in a foot bath.
I'm receptive.
You guys just come in with the old back on your desk.
I've had my hippie days. I want to be the stinky guy.
Oh, man. Are you serious? I let my kid be the stinky kid in class? Okay. How are we doing now? Because we're done. For now. And we can make this more and more complex now. But like I said, like getting the core of this application running. Actually, I do want to set self.winners equal to the sorted. And then down here, I'm just going to print self.winners 0 is my winner. Print self.winners 0. And then we want to get their position. So we have the duration, we have the name of the winner, and we have their position. There we go. Their position was 101. They went over the finish line. Seems like most people, okay, 103, 104. Most people go a little bit over the finish line. Cool. Now, you can look at how long it takes for the race to finish. Like this race took 30 to finish. I'm going to get rid of this debug print here. This is a little annoying. There we go. We can see how this program plays out. If I want my race to be a little bit longer, I'm just going to lower the chance that it can speed up to 70%. There we go. Our race got a little bit longer. Now I'm at 60, 66, 55. You know what? Let's add that to 80. So all bikes are going to slow down now. The more I take this towards 1, or no, 0.9, can't make it 1 because that doesn't count. See how like statistically it's getting more and more closer to, like we have a 1 in 10, well, this is a 1 in 10 chance of increasing your speed. Whereas if I was to say, you know, the races are barely going to take any time. There we go. 23. But I like it at about 0.5. All right, so that leaves us a little extra time, and I'm really glad about that because I wanted to talk a little bit, I want to show a little bit more examples of that will help you with tonight's currency converter project. Because currency converter project can be really lame if I don't talk a lot about it. So I kind of want to give a brief synopsis of what I'm looking for and show you some helper ways, give you some code, and I'll paste it into your Slack so that it will help it out. So what I don't want to tell you, I don't want to show you like this is how you convert currency because that's your homework. What could I use this as though? What could my contrived example be? Let me take a second and think on this.
While you're doing that, can I look at the last things you did?
Sure.
The last prints.
Here you go. Long, awkward silence around 11:17. It's my favorite part of the class. Let's take a minute and just think about that. So I want you all to kind of see about having her. Okay, let's make a class that will take some things from week 1, and we'll pass it a string, and then we can do crazy things to that string. Like let's implement our own string class. How about that? And so we can we'll pass it a string of characters, and then we can implement our own capitalized functionality. We can implement our own lowercase functionality. Do we want to do that? Don't want to do that. Don't want to convert it to binary. That's too much of a jump. Pig Latin, we already have that code. We could adapt that to Pig Latin. Yeah, let's do that. Let's make a class that we can pass it a word, and then we can convert it between like English and Pig Latin. Because that's a conversion, right? Sorry, you guys are just like, just make up your damn mind. I just want this to go so right. I'm really nervous that I won't do a good job. Okay, let's do that. Let's just dedicate to it. So I'm going to make a day 3 file here. And we're going to call this piglatin.py. Okay, so ultimately, I'm going to make a class that allows me a clean interface for like translations. And it doesn't have to be Pig Latin. Maybe we can make I think, yeah, that's perfect. It's not Pig Latin, but Pig Latin is one of the options. Like we can make a translator class. So where it might convert it to Pig Latin, it might not. It might convert it to some other thing that we made up. Maybe make it like we can make it loud or something like that. Anyways, let's make a class and we'll call it translator. And what I want to do is I want to be able to give the translator a string, and then I want to say I want to see this string as Pig Latin, or this word as Pig Latin, like to Pig Latin, which is kind of similar how what I'm expecting you to do with your currency converter. I want to see this currency as JPY. I want to see this currency as USD. So what I'm going to do is I'm going to create an initializer, my constructor for the translator. And I'm going to pass it one argument, which is going to be our word. I'm going to say self.word is equal to word. This is going to be similar to how you do it tonight. You're going to have your currency amount and your symbol. Your currency amount will be like $40, and your symbol will be a string of US dollars, because you need to be able to give those two pieces of information. But I'm just going to do self.word here. And what I'm going to do is I'm going to create a method that's called toPigLatin. Self. I might have to cheat and just go grab all of this toPigLatin code here. Is that functions? Oh, day 4 helpers, huh? Do I really want to copy and paste all this over? This seems unnecessarily complex to do this. Maybe we just make up our own translations then. Maybe that's what we do. Let's call it toJoel-Latin. How about that? And Joel-Latin is awesome because Joel-Latin is reversed and the character at the front is in the back. I just made that up on the spot. So to convert something to Joel-Latin, I'm going to return my self.word, and I want to reverse it, right? So how do you reverse a string?
Brackets,
Colon, -1. All right. And how would I put the first character in the back? So I want to reverse it, and then I want to take the character that's at the original first character and put it at the back as well. So it's like bookends. So if it's like if the word is book, then the Joel Latin will be KOOBB. I know it's contrived, but the business requirement here is that I'm just going to put self.word 0 right here. So let's play around with this now. I want to create a translator. This is my, say, t is equal to translator. And I'm going to pass it a string that is face. And if I was to print t dot to Joel Latin, I want to show you what that will look like. Python day 3 pig Latin. ECAF. Is that what we expected? It is what we expected. But what happens right here if I print t.self.word? Oh, not t.self.word, it's t.word. What happens when I print t.word after I call to Joel Latin?
That'll print because it's changing. So right now it's not changing it. So it'll just print the word in the right place.
We don't change it. You don't change the original amount. You really should not change the original amount. Okay, so let's take this a step further. Let's say that, gosh, this really is like most of your project, but it's not doing any of it. Let's say that on top of this translator, I want to pass in the language that it is. So what I'm going to do is I'm also going to pass in the language. So what happens? So what I want to do is I want to say if something is already Joel Latin, I don't want to convert it again. So this face is going to be English. And I'm going to set my language equal to language. So now I could potentially get language getting passed into my translator that is Joel Latin. If I get language that's passed into Joel Latin, do I want to convert it to Joel Latin again? No, because that would be all screwed up. So I would want to guard against that by saying something like, if self.lang is not equal to Joel, I want to return that. Otherwise, what do I want to do? What do I want to return? Self.word, correct. So this is saying that as long as the language isn't set to Joel, return the word as Joel Latin. Otherwise, just return Joel. So when we look at what that looks like for our interface, okay, we know that word's not going to get changed. When I say I want to convert face that's English to Joel Latin, whoops, let me go ahead and fix that. It's going to convert to Joel Latin. Also, though, if I was to say x is equal to translator of ECAF, that is in Joel Latin, and then I printed t.to Joel Latin. Watch what would happen. It won't convert it. So, little bit's going on here. I'm saying that I have a word in the language. If the word is not of type Joel, we want to convert it. If it is of type Joel language, it doesn't convert it. Maybe what we can do is, as well as we can say we can translate it, we could say to English. And I can reverse engineer the Joel Latin. And so if I want to convert my Joel Latin word to English, I would just return, and this, I'm just going to give this one to you. I'm going to reverse it again. But I only want,
So you gotta remove that. If you reverse it again, you'll want to remove the very first one.
right, so we've just done this here. So first, like, this will get the second character to the end in reverse. I think we can do this. And then I'm going to say that I want to convert this to English, the bottom one. So if the bottom one should say face, it's AF. It's AF, AF. You guys get that. So what did I do wrong? I knew I was probably going to do something wrong here. Okay, so I dropped the last character just by reversing it. Oh, because... How is that even working? It doesn't make any sense. The second print should not have dropped that first F.
When did it drop the...
It shouldn't have dropped anything.
If you're telling it to start at 1, it wouldn't have started at the C and then worked backwards.
Well, see, the thing is that I just took this here. I'm just reversing self.word. Oh, wait. My codes is t.toEnglish. It needs to be x.toEnglish. There we go. So I reversed it back.
Can we just do... Well,
So if I say -1 to 1, will that work? That would be confusing. That's definitely not right. This always kind of throws me for a loop.
Just do minus self.word 0 after that.
Minus self dot. What do you mean?
Minus self.word, you added the first letter.
We
Just take off the first letter. And that would be face.
I don't think subtraction works that way with concatenation. We could do another slice here. We could just slice and dice the crap out of this thing and say we want to get from the first one to the end. That would work. But we also need to guard against to English as well. We don't want to convert something again. So I'm going to put in my if self.lang is not equal to English. Do that. Return, or else return self.word. Now I want to show you this really cool trick that is going to be very useful in tonight's homework. And I think you all will really like this. So when we're converting, what is the type of data that we're converting? Like, or not converting, what are we returning? What is the type here that we're returning? It's a string. So what if I wanted to say like to Joel Latin dot to English to do a whole other thing? Can I do that? The answer is no, I can't. Because a string does not have a to English method on it. Python's not quite that advanced yet. What we can do in order to do that, by the way, does anybody have any idea what they could do to do that?
So if you wanted to take something that was not English or Joel Latin, but then convert it to English through Joel Latin.
Well, no. What I was asking for is if I wanted to chain translations so that I can say I want to start off with face that's in English, convert it to Joel Latin, and then convert it back to English. What would be the best way to do that? This is not something we've covered before, so this isn't like a refresher or anything. This is a new concept that is incredibly fun. Okay, I'm just going to give it to you because it's too hard to resist. What we're going to do is we are going to return, instead of saying self-word, we are going to return a new translator object with this as the first argument and Joel as the second argument. What the heck is going on? And then for here, we're not going to return self.word. We're just going to return self. And we're going to do the same thing down here is we're going to return a new translator, because this is absolutely, you can do this. And I'm going to say that this is an English word. And here I'm just going to return self. So what the heck did that do? Because that's some next level advanced stuff going on right there. But what this is doing is that it's allowing us to convert, and instead of returning a string, it gives us another translator object. So watch what happens here. Let me make this interactive. I'm going to say from day 3 pig Latin import translator. Okay, cool. It did all this work, doesn't matter. So I've got a translator object. I can make a new one. So I'm going to say x is equal to translator. And let's give it face of English. So if I want to convert that translator, first off, I can see the word by saying x.word. But if I want to convert and get a new version of this, not change the original one, but I want to get a new version of this as a different language, I could say x.to, is it Joel Latin? And that gives me a new translator object. So I can say .word, and then that will convert it to Joel Latin. So I could say y is equal to x.to Joel Latin. Now this is going to start getting a little crazy because when I say y.word, that's neat. But what if I wanted to convert y back to pig Latin, or to Joel Latin, or to English? I would say y.to_English.word. And that would convert it back. So this is, like, it's really convoluted, but this allows you to call them over and over again. So I can say, remember, x is my first translator object. I could say x.to Joel Latin .to English .to English .to Joel Latin. And this is perfectly valid here. So what do you think is going to come out when I say .word? It's going to be in Joel Latin. So this is kind of cool here, is that if this was in your currency converter, you would be able to say, I have a JPY currency. I want to convert that to US dollars. I want to convert that to Bitcoin. And I want to convert it back to JPY to see if there was any conversion loss in the process. Like did Superman, or did Richard Pryor in Superman 3 steal a millionth of a penny in the process? You don't have to do that, but it's a cool way of thinking with objects is that, and JavaScript does this a lot, like a lot. You'll have a method that returns a copy of itself, or not a copy of itself, but a reference to itself, so that when you want to say, like, you're never actually changing word. Like, I want to make sure that that's abundantly clear. In your currency converter project, you never change the value of that is initially stored. You will convert it and display it to the user. So if you say I have 5 US dollars, what is that in euros? You don't change the underlying currency to whatever that is in euros. You just return the value that's been multiplied by whatever the multiplier is. And if you want to, like in the harder mode, you can say, you know what, instead of just returning the value of 10, I want to return a new currency object that has the value of 10 and a symbol of euro now, because I'm returning a new version that's been converted over. How are we doing? How are we doing on this? Gonna go back to the bike race and make it a little bit more complex? Or what do you want me to dig deeper into? You want me to dig deeper into the translator or the bike race? What's feeling the less comfortable? Testing a win condition of tic-tac-toe? Okay. We can start going down that route without giving too much away. Yeah, we could do that.
So, question, where you have Teams translator and then we're inputting face, like that's what
Yeah, that's going to be the word. Like that's the first argument here.
And you could change that to just be input.
Like you mean up here?
Like where would you change that? I'm having a hard time like relating where you put in input.
Oh, so with your currency converter project, it's just going to look like this. There's no user input required. You're not building like a user interface like we've been building. So what you turn in should look similar in structure to here's my currency converter, and then down here I'm going to show that it can do some conversions and print out the values. And that's really all you got to turn in. So you can hard code your inputs. You just have to demonstrate that you can convert from different currencies. So you can say like, I want to convert this US dollars to JPY. Okay, so I'm going to create a US dollars instance, and I'm going to say to JPY, and then that's going to show what I need there. And then I think there's like 4 of them: Euro, US dollars, JPY, and Bitcoin. You have to implement all of those conversion functionalities. And so like it's really easy. Well, not it's really easy, but the normal mode is to get US dollars to everything else. I think hard mode, it might be a normal mode too, but the challenge is to get from like Bitcoin to JPY when you have the 2 US dollar conversion rates programmed in. So yeah, you have to go online, find all of the current rates, whatever they are. I know they change like daily, so I'm not like, we're not going for accuracy to the 10th of a percent. Within $1, I think is accurate enough. And I just want to make sure that the conversion happens correctly. Because that's why I picked those 4 conversions. Like US dollars to JPY is incredibly different units. It's like something like 100 JPY to dollars. Euros to dollars is fairly similar though. That's like 80%, I believe it is, or at least it was a while ago. And then Bitcoin is wildly different. It's like $1,000 to, or whatever it is now, to a Bitcoin. So it just shows of storing the conversions in different magnitudes. That's what I'm looking for. All right, so there were some questions about win conditions. There was a question about win conditions in tic-tac-toe. Okay, I mean, so that's actually pretty similar to the game of life that we were doing yesterday. So let's take a look at the game of life, and let's just analyze some of that code. Oh, here we go. Who loves programming now? No, that was probably a little unfair of me to drop that on you. This is not where I expect you to be as a programmer right now. So like, if you look at that code right there and your eyes cross and you're just like kind of panicked, I'd say that's right where you should be. So don't worry if that is like completely overwhelming. That was not necessary for me to cover. But what is important is this right here, the score. And let's talk about how we got to that score without all the business of, what's going on here. Is that we looked at certain indexes in an array. Because what is a tic-tac-toe board? Then something that looks like that, right? Or did I get that wrong? That's wrong. An array, those are 3 rows. There's your tic-tac-toe board right there. You have your top left column, you have your middle left column, and you have your bottom left column. Can I see where I'm going here? You have your top middle column, you have your middle column, and you have your bottom middle. So if we were to look at each one of these lists here as an individual entity, that's a row, that's your second row, and that's your third row. So I'm going to put some values into here. So TTT, I want to set, first off, let's play Battleship a little bit here. If you want to set the exact middle, like if you want to, wait a second. Those don't need to be lists, do they? They don't. That's cool. So if I want to set the middle to an X, not an empty list, how would you do that? By index. Like, what would the indexes be if you want to set the middle to 0? So if I said square bracket 1 is equal to 0, let's take a look at t, whatever it is, and show it. There we go. My middle now has a 0 in it. I probably should have used a 1. Let's do a 1. There we go. So now what I want to do is I want to set my top right to 0. Or maybe 2. Let's do 0. Let's do 0. Doesn't matter. I don't really know where I'm going with this right now. So what would my indexes be if I want to set the top right to 0? Okay, so if I say TTT 0, meaning the first row, and the second column, or the third column, I want to set this to 0. Now let's take a look. So I would expect this one right here to be 0. And there it is, 0. So as I populate the board here, I have a win condition. This win condition, this is one of my favorite ways to get a win condition. And the easiest way to do it is the way that I would want, this is a way that I would want you to explore it. So if you were to say that that's my win condition, that is, there are going to be 3 1s in there. So I can say, what's TTT 1 would give me that row. What is the count of 1? It's 3. What is the count of 0? It's 0. So if you have each player would be like an X or an O, you can ask for the count in that array. So if the count is 3, you have a win. Notice that I did a count of 0. If I try to do a count of X, there are no X's in that array. So that will be
Count will work on strings too.
count will work on, yeah, so if I have a list of X, Y, and Z, and I say count the X's, it'll say 1. Now if I was to say if there were 2 X's in there, it will count the occurrences of X's in there. So it doesn't matter what it is, as long as you as a programmer know what to expect. So like if player 1 is an O and player 2 is an X, like a letter O and a letter X, you just look for that count. Now a horizontal win condition is the easiest to do there. So let's take a look. I'm going to go ahead and redefine my initial board here to not be arrays. I want this to be like an underscore. Yeah, let's just do underscores. So I'm going to do this the cheap way. Ah, come on. Oh my gosh, what did I do? Underscore times 3. Oh wait, no, you can't do that. Oh yeah, you can. Why not, right? There's a million ways to do this. This is just one of them. I'm really going to confuse you guys now. Because I'm going to change my game board here. Oh wait, no, you can't do this, can you? I wasn't prepared to talk about that one, but you could do that. But you can't, though, because strings are immutable. So I can't say, like, TTT01 is equal to X. You can't do that. So probably the way we're going to have to do that is like this. There we go. That's what we wanted to do. Okay, so what I want to show is that above here, getting the horizontal wind condition is the easiest thing. Because all you have to do is like, I want to get that row, be it the first row, the second row, or the third row, and count up all the ones. Getting a vertical wind condition is a little bit harder because you can't just add up all the ones. But what if I said there was a way that you could get a vertical wind condition? Like you could get a vertical of the column and turn it into its own list. I don't know if I want to do this though. There are much more manual. Like I'm jumping right to like the really clever way to do it. I don't know if I want to do that. There are many more manual ways to do that. Like you can look at each individual index. Say like, since you are dealing with 9 spaces, you just say, is there a win in these 3? Is there 3 of a kind in this row? Is there 3 of a kind in this column? But I don't know if I want to show you all the way to turn a column into a flat list. Because I think that might involve either a lot of code or something we haven't covered yet. So let's see. So if I have 4 row in TTT, print row. Right, so I can do that.
You basically have a new.
So
Create temporary list.
yeah. So if you wanted to get the first column, there you go. You have 3 underscores. If you wanted to get the second column, or the first column, you would look at 0 and 1. Now the thing that you would want to do to get those to be their own list that you can look at would be this new thing here. And this is why I didn't want to show it, because it's incredibly new. Is you can use what's called a list comprehension, which is sort of an inline for loop. And you can say print, and let's see, the variable would be underscore. No, it wouldn't do that here. Okay, yeah. This is really, we're not ready to talk about this because this would require 2 levels of list comprehensions.
So, I mean, you do it just with a regular. So you basically, if you have.
Okay, we're gonna sum this up. We have to wrap this up because we've gone completely off the rails. Let me just say, if you've got a board like this, and you want to see if there's a horizontal wind condition, that's your top left. Whoops. This is your middle left, and that is your bottom left. This is your top middle, right? 0, 1. This is your middle. That's your bottom middle.
No, would it be 2, 1?
Yeah, you're right. I went too fast. Yeah. You know what? Let's do this. Let's make it a little bit easier to visualize. We're going to put letters in here so we can make sure we know what we're seeing. Because what I want you to see is that there's a pattern. And I don't want to give you the algorithm because I was dangerously close to giving you the algorithm there. But what I want you to do is I want you to derive a pattern and build your own algorithm for that. So if I was to see TTT 0, 0, that's A. Now ABC, like TTT 0, that's a win condition that I can just look at right there. So horizontal win conditions, we can all agree, are super easy. The difficult ones are the vertical ones. So if I wanted to get I want to get A, D, and G, I would do TTT 0, 0, I would do TTT 1, 0, and TTT 2, 0. That's A, D, and G. Look what happened here. 0, 1, and 2.
What do
Do
you
you-
mean by in terms of the double brackets, then going across, the first bracket's going to stay the same number, and the second one's going to advance. And then if you're looking down, the second number's going to stay the same as the first one.
Correct. That's traversing a matrix. That's saying that if you so basically what he just said was these three lines of code 0, 1, and 2 go up, and the 0 and the second bracket stays the same. That's your column. So this is your row, it's going up, and this is your column that's staying the same. If you want the row, then that means that the first number stays the same, but that number goes up. You see, you find the pattern here? Now, how do you get a number, let's do list of range, between 0 and 2? Whoops, 3. What's that?
What was the question?
So let's say that I want to iterate between 0, 1, and 2. I can ask for a range of 3. So if I was to say for range of 3, or for underscore in range of 3, and I just print it off. Now we want that 0, 1, and 2 to go up, but we want the 0 to stay the same. I'm just going to print TTT underscore, but 0. That's my column. There you go. So we're reverse engineering what the numbers are going to look like, because you want to solve this algorithmically. You don't want to solve it by hard coding, looking at every index. Like, that's a great way to start. That's not a great way to finish. And what I'm saying is that if you want to get essentially a column, you increase the value of the first index, and you leave the second index the same. If you want to get the value of a row, so 1155, I make this point. If you want to get the value of a row, you leave your first index the same, which is the row you want to get, and you increase the second index, which is the column. I like leaving it there instead of showing you how to. And there's a really fun way that you can convert these into their own lists. So when you can convert a column into a list, not a list of lists, but just a flat list, then you can just count up the X's or the O's, because that will show you, oh, all of these, there's 3 X's here. There's a win. There's 3 X's. There's 2 X's, so it doesn't count.
Do the same thing diagonally, you just have to iterate through it a little bit.
Yep. If you do it diagonally, what numbers do you think increase? Like going from top left to the bottom right,
Bottom right, they're going to increase at the same rate.
they stay the same.
If you do,
Top right to bottom left. So like,
well, you could go,
so if you
could
want-
go
so-
bottom left to top right, or
so what we're saying now is that if you want top left to bottom right, they both stay the same. But if you go top right to bottom left, they're flipped.
yeah.
So you have first row, last column. 1, 1 stays the same. That's the center. And then you have 2, 0 here. So these are diagonal win conditions. This is a horizontal win condition for a given column. So there's only 2 diagonal win conditions. That's the good thing. But yeah, I don't want to see this. I don't want to see the index is hard-coded. That's fine if you want to get started that way, so you could say, hey, I have this checking for a win condition. But I would like for it to look a little bit algorithmic. And you can, I guess you could hard code, you should hard code the algorithms that do that checking. All right, I'm going to stop the recording now.